Before we start, we will give you exactly 30 seconds to try answering this on your own, together with the questions that can be found on the right-hand side of your screen. If you think you need more than 30 seconds, you may pause this video before the start of the discussion. If you think that you don't need the 30 seconds, you may skip this video to the portion of the discussion. Your 30 seconds starts now. Let's start. Now, we have here a binomial expression, specifically x plus 3y, and the entire quantity is raised to the power of 4. We are going to expand this using the appropriate operations and see what are the correct terms together with their coefficients that comprises the entire expanded form. At the same time, we are going to answer these questions here, so that which we can use as part of our analysis. And some of these questions, specifically the last two questions, can only be answered if we are done with the expansion. Okay. Now the trick here is this. Of course, one thing that we can use here is the Pascal's triangle. But before that, let's try to examine and answer the first question. How many terms are there in the expanded form? This will help us decide which coefficients in the Pascal triangle will be used together with the coefficients of our binomial expression. Our n here corresponds to the exponent of the original given. So n is equal to 4. That's our exponent here. Okay? Now, if we have n which is equal to 4, the number of terms in the expanded form is actually n plus 1. Again, the number of terms in the expanded form is n plus 1. Hence, if we have the exponent here which is 4, we expect to have 5 separate terms in part of our expanded form. And this is also a guide in determining the correct coefficients. At the same time, we'll also be guided about the correct process later. Now that we are sure that there are 5 terms in the expanded form because of this process, let us try to come up with our Pascal's triangle. Of course, we start with 1, and we have here 1 and 1. We place 1 here and we add 1 plus 1, 2, and 1 here, and so on and so forth. 1 plus 2 is a 3. We have here 3, and then 1. If we're going to continue, we also have 1 plus 3 is 4. This is 6. That's 4, and that's 1. If we move further, we have 1 plus 4, which is 5. 10 is also 10. We have here 5, and this is 1, and so on and so forth. We can continue with the idea of this Pascal triangle, but we already have a mark on what would be the correct coefficients. Take note that there are 5 terms here. Hence, we pick the row with 5 coefficients, and that is this row here, the row of 1, 4, 6, 4, and 1. We have 5 coefficients here, corresponds to the 5 terms. In short, the expanded form will have these coefficients, but this may not be the final coefficients, but preliminary coefficients. We have 1, and then you will have here plus 4, and you have here plus 6. Why do we use here plus 4 and plus 6? Because they will be combined into one expression. Okay? At the same time, we are using here plus. Of course, there's no harm here because our operation here is plus. But if this is minus, we can still use here plus and just change operations later depending on the nature of the presence of a negative sign. So let's continue. 1, 4, 6. We also have here plus 4. And the last coefficient is plus 1. Again, these are not the final coefficients. We just have these preliminary coefficients, may be changed depending on the nature of our terms later. And speaking of terms rather, we have x here, and the second term is 3y. After we are done plotting these terms from our Pascal's triangle, we are going to use this concept. These two terms of our binomial expression will be expressed in an exponent in a specific order. For our first term, which is x, its highest exponent should not exceed 4. So it's exactly 4. And then we go down or decrease the exponent. 3, 2, x to the power of 1 or 1. I mean, we don't need to write 1 there. And we have the x to the power of 0, which is just equal to 1. So we are done with the exponents of the first term. Now for the second term, we also do the same thing. But since it's the second term, we're going to do it reverse process. So we have here y, and we start here with 4. But this is actually incorrect if we're going to move like the next one is y cube until you reach here y to the power of 0. What makes this incorrect is that our second term is not just y. It's 3y. So you need to place here 3. This is still incorrect because we are taking the entire term and raising it into an exponent. This should be with parentheses. Take note of that. This is also true here. We're going to use here parentheses. Don't worry if our first term is just x raised to an exponent because automatically it has 1 and we have 1 here, so on and so forth. And if you're going to include it in parentheses, 1 will still be 1, right? So it won't matter. So, however, if the coefficient is not 1, it's 3 in this case, or even negative, we need to enclose it in parentheses. So as we move further here, we have 3y, not just y, but the entire expression raised to 2. We have here 3y. Of course, that's automatically raised to 1, or just itself. And we have here 3y raised to the power of 0. That's the pattern, okay? 4, 3, 2, 1, 0. If you would like to, I could place 1 here. And we have here 4, 3, 2, 1, 0 in reverse order. What are the uses of these coefficients? Each of this pair will be paired with the coefficient in our Pascal's triangle. Hence, we'll have here 1 times x to the power of 4 times 3y raised to the power of 0. This is the entire first term. Not yet simplified, but this is the entire first term. Okay? Next, plus 4. The next pair is this. Okay? So we have x cubed times 3y raised to the power of 1. Then, plus 6. Let's have the next pair here. X squared. Then we have 3y to the power of 2 plus 4, and we'll have this pair here, x to the power of 1, 3y cubed. Finally, plus 1, you will have your x to the power of 0 here, and the last term is the expression 3y raised to the power of 4. Now that we completed the necessary coefficients according to Pascal's triangle and this pattern here, let's simplify them one by one. Of course, that's 1. We have your x to the power of 4. And any expression, term, coefficient raised to the power of 0 is just 1 itself. So x to the power of 4 stands alone. Plus, you have 4x cubed. When you raise this to 1, it's just 3y itself. Let's just simply write it in the meantime because we also need to express the rest. We'll have here plus 6x squared. And here comes the exponentiation of 3y. Y squared is correct, but the 3 is not just a 3. It's a 3 squared. Common mistake, 6, right? But 3 squared is 9. How do we write these two without any problem? Since we have two numerical coefficients, enclose still with parentheses so that you will not be combining them into a singular number, but you will be multiplying them later. Same as to with this, and just like what happened earlier, you have 4, x to the power of 1 is x, times 3 cubed is 27, and we have y cubed, right? And you have your plus 1, this is also 1. We have 3 to the power of 4 is 81 y to the power of 4. To finalize, let's simply multiply what needs to be multiplied in the rest of the terms. Sorry, that's x to the power of 4, my bad. Plus, here comes the product. 4 times 3 is 12. You have x cubed and y alphabetically. Notice what I meant earlier with saying 4 and the rest of this like 6 and 4 to be not the final coefficients. Okay? They are just preliminary coefficients since one of our terms has a numerical coefficient instead of 1. That's why we have 12. And this is also incorrect to say that the numerical coefficient of the fourth term for the last question, you will automatically say answer 4. No, because then again, this could be answered using the final form. Let's continue. You have 6 plus 9 is 54 x squared y squared. Plus, you have 4 plus 27. So you have 108 because that's 54 times 2. 108 x y cubed. And finally, again, 81 y to the power of 4. Since we don't have any other terms that can be combined, this is now the final expanded form of the given expression. And this time, we can answer these two questions. What is the second term? It should be the entire term. The second term is 12x cubed y. And the numerical coefficient of the fourth term is not 4 as mentioned. It's the numerical coefficient of this term. So it's 108. This is why it's very important to enclose these terms with parentheses because it has a numerical coefficient aside from 1. So this is the expanded form of our given, and this is the final result together with the correct answers here. So please don't forget to subscribe and continue following us for more videos related to this and other math related subjects. Thank you very much for watching. See you next time.